Webcast is now starting. All attendees are in listen-only mode.
Excellent. Welcome, folks. Thank you so much for being here today. I'm Gunderson, one of the presenters for this session of Passive House for Builders and Contractors. I know we have quite a few people registered, so hopefully we'll get some folks trickling in here. We got quite a few already. For those of you who are here, the chat room is open, so feel free to use that for the questions and discussions as we go through the presentation. But we'll do introductions to the speakers here in one moment. First, I want to talk a little bit about where the session's coming from today. This is being put on through part of the training program that Connecticut has started. I'm coming to you from Massachusetts. Actually, all of the presenters today are coming to you from Massachusetts, where we've had some passive house incentives and training programs in place now for about 3 years. Have been going really successfully. I'll show you some of that here in a bit. But so we're excited to see Connecticut roll these out, and we're looking forward to kind of what goes on here in our neighboring state, and we're happy to be kind of presenting to you guys today. So with that, I'm going to turn things over to Anna and Keegan to talk a little bit about these incentives that are now available.
Thanks, Aaron. Yeah, hi, my name is Anna Zylik, and I'm with ICF, and we are the vendor working on behalf of Energize Connecticut to bring these Passive House trainings to all of you, so thanks for joining. Just a few reminders that we will be recording this training and we'll make it available to you all afterwards. And these trainings are at no cost thanks to the sponsors of Energize Connecticut, and also in partnership with Connecticut Passive House. A reminder that the Energize Connecticut program is also offering 50% cost reimbursement for professionals pursuing either FIAS or fee accreditation trainings. So this includes the cost of the training and the exam, and once you become certified, we'll work with you to process the 50% cost reimbursement. So if you have any questions, please don't hesitate to reach out to us. With that, I'll pass it over to Keegan, who's also with ICF, to talk about the building incentives.
Thanks, Anna, and yeah, thanks to everyone who's joined. Welcome. We're really excited for this session today. So in addition to this training initiative offered through Energize Connecticut and the professional accreditation reimbursements, the sponsors of Energize Connecticut are also proud to offer incentives to builders and developers of multifamily buildings in Connecticut that pursue passive house level design and certification as part of the building process. So multifamily buildings being 5 units or more. Aaron, if you want to go to the next one. The incentive design is broken up into a few different phases to incentivize the process along the way, including feasibility studies, energy modeling, and post-certification incentives as well. So if you're interested in learning more about this for a project that you might be working on or know of, there's information at the bottom. Check out the website or certainly give us a call or feel free to ask questions today in the questions chat. So with that, I will pass it off to Aaron, and we'll get underway here.
Great. Thank you, Keegan, and thank you, Anna, for all your work on these incentives and in organizing the session here today. So like I said to folks when you first joined, my name is Aaron Gunderson. So I'm with Passive House Massachusetts. We do a lot of work in, of course, up in Mass. I'm a certified Passive House trade person as well, and I spend most of my time these days doing a lot of these trainings and education events to a wide variety of audiences, as well as doing some advocacy and community work to try to get more Passive House incentives and low carbon building funding and zoning and things along those lines. So I'm excited to be here to talk with you guys, but I have two great co-presenters today with me, and I'm going to let them introduce themselves here before I go on. So maybe we'll just go in the order here. So Nat, do you want to introduce yourself quick, and then Ed?
Great, thanks, Aaron. Yeah, my name is Nat Coughlin. I'm the president of LD Russo Construction up in Harvard, Massachusetts. We've been involved in Passive House for about 3 years now, and I'll present a little more on a couple of projects later.
Good afternoon, everybody. Ed Sople from Dellbrook JKS, Chief Operating Officer. Have been involved since early 2019 with Passive House, and As Nat mentioned, I'll go through a little bit of the company history as well as dive into one of our first jobs, which is the loop in Mattapan Station, and go through that process when the time comes. But happy to be here and excited for the questions and answer session as well.
All right, excellent. And we'll hear from Nat and Ed both here a little bit later. First, I'm going to start by just going over a background of a little bit about Passive House, kind of what this certification means. We'll talk a little bit about some of the common say building principles of how we construct passive house buildings before we hand it off to Nat and Ed to give you some concrete examples from their experience. As we go through this, the chat room is open, so if you guys have questions that come up or you want to discuss certain topics, just type them into the chat room. We can address stuff that way. So feel free to do that and ask anything you have. So first, just a little collage of a bunch of passive house projects. Most of these are in Massachusetts. There is one New Hampshire one here as well, the one that's red in the top corner. This just gives you a scatter shot of what passive house buildings look like. I'm sure you guys attending this session are kind of aware that we're talking about a lot of bigger projects these days when we talk about passive house. But I know it's a common misconception to just picture like a small single family home because of the name, passive house. But really, we're talking about passive buildings. And these days, mostly large residential projects are the kind of the main driver of the growth of passive house, but we're also seeing some commercial and industrial buildings as well. The one in the bottom right corner, for example, is going up in downtown Boston right now, and when it's finished, it will be have the largest square footage of certified passive house office space in the world. So we're pretty excited about that one, and hopefully we'll see more of that in some future presentations. Here's some examples of some stuff going on in Connecticut right now. There's lots of new passive house projects going up. I just have a few examples I wanted to show you guys so you kind of know what's happening in your neck of the woods here. This is one in Meridian there, a combination. So there's 3 buildings of apartments, and then there's a row of townhouses. So you're looking at the townhouses on the screen, but all certified passive house there. This is Oak Tree Village. So the 2 buildings in the image on the sides are the residential units, certified passive house. The middle one with the solar panels is sort of like a clubhouse office for the development there. But that with the solar panels, I believe that place is also attempting to be net zero in addition to passive house. This is the Tyler, a very innovative passive house project. This used to be a school, and it was renovated through the EnerFit program, which is a program for existing buildings to go passive house. And turn into a residential complex there, 70 units. So a fantastic work there to kind of both preserve the outside of it, kind of looking like the old high school still, but being a passive house residential place on the inside. And then you got Columbus Commons here, 80 units. So this is just an example of projects going up in Connecticut right now. There's a lot more happening. There's going to be a lot more growth, and hopefully you guys are going to be involved in them. So let me tell you a little bit about what passive house is. So the main things are the highlighted ones here. Passive house is performance-based standard. So as opposed to maybe some other building standards you may be familiar with that sort of are more checklist or prescriptive, passive house is based on performance. And that performance is, focused on energy use. So passive house, wants you to reduce the energy use, the energy demand of projects down to a significant amount. And we, base that on the actual performance of them. And I'll go through that a bit. But what you achieve through this is obviously the reduction in overall energy use and the corresponding reduction in carbon emissions, which is the real reason that the standard exists, is to reduce those carbon emissions. But beyond those things, we see a lot of other benefits. And these things are becoming, I think, more increasingly important for why, say, developers are choosing passive house for their projects, especially this third bullet point here, the proven improvement in air quality, so indoor air quality, occupant health, occupant comfort. We notice a lot, air quality, especially over the last couple of years, and ventilation rates have become a larger part of the conversation. And passive house really delivers on these things. So it's become a larger reason for projects to go passive house. And we're also seeing greater building durability and resilience to major weather events, all sorts of things. A story I like to tell is how last summer we had a lot of power outages up here in Massachusetts. You may have had some in Connecticut as well on really hot days. So people in traditional homes or traditional residential units that relied on electric AC had no power for a while and no AC, and their homes got really hot and uncomfortable. But if you were in a passive house building, which some folks were, even though their AC was out as well, the passive house building was able to maintain that cool temperature for a lot longer. So they were able to withstand the power outage in a very cool, comfortable building in the hot summer. And that's one of the other things that passive house provides and what we mean by resilience to weather events. In addition, you get lower operating costs, of course, with lower utility bills, and then a pathway to be net zero. By reducing energy demand so significantly, you make it a lot easier to become net zero on site. So when we talk about performance reduction in energy use, what are we actually talking about? So I have a couple examples just to show you. So this is the distillery. This is a multifamily project in Boston. It's actually the first multifamily passive house in the state. And it uses, as you can see on here, 60% less energy per square foot than typical mid-rise buildings in the Boston area. So really significant improvement. And that 60%, is a pretty average rate for what we expect from a passive house compared to a typical non-passive house building. This is a project up in southern New Hampshire. And I like showing this because this was built in phases. The first phase we don't really need to worry about, but the second phase was built to LEED standards. Then the third phase was built to passive house standards. And other than those differences, they were similar projects, in terms of architecturally or number of units, things along those lines. They were very similar. But you can see the passive house project had 61% less energy use than the LEED project, just by going passive house, doing those extra steps to use more efficient equipment, better building envelope, more air tightness, these types of principles that we're going to talk about today got a 61% greater reduction in energy use than a similar LEED project. And so that's the reduction. We've also seen a growth in the number of projects. So this is just showing you sort of the Northeast region, Massachusetts, Pennsylvania, New York, and Connecticut, the 4 states in this area that have traditionally been leading the way in passive house. So you can see New York historically has been the big leader. Well, maybe Pennsylvania back, kind of had a small lead, then New York jumped on it. You can see Massachusetts in the last couple of years has jumped up now to be the leader. And a large part of that is due to these incentives that were made available in Massachusetts starting in 2019. Connecticut is, you can still, you're small on there, but we're projecting that with these incentives that are now available there, that Connecticut's going to have similar growth to what we've seen in Massachusetts. At least that's the hope. So this is kind of both showing you what has happened in Massachusetts with incentives and possibly what you can look forward to happening in Connecticut. In addition to incentives becoming available, we're also seeing a reduction in the costs to achieve passive house. So, the incremental cost, basically the comparison between what it would take to build the passive house project versus a comparable but not passive house project. And 1 to 3% is pretty common these days, especially, in this multifamily mid-high rise sort of scale that we're looking at today. That's really 1 to 3% is pretty common. So that's kind of what you can kind of rely on. So we've seen the cost come down from where it used to be and more incentives available. And as well as a lot more training initiatives to get folks aware of this, get builders, contractors, architects, developers, engineers, everybody on board with what's different about passive house projects has helped to really just increase the amount of these projects we're seeing. So now I want to take a few moments to actually talk about what passive house is. So as I mentioned, it's a certification for buildings that's based on performance. And that performance is kind of in 3 categories. You can think of it. So you have heating and cooling demand. So we look at the overall energy use to heat or cool the building. Then we look at whole building air tightness, so how airtight the project is, and this is measured on site with a blower door test, a whole building blower door test at the end of construction. And then the final metric is source energy demand. This is just a way of talking about the overall energy use of the building. So there's specific metrics for heating and cooling, and then there's metrics for the overall energy use as well. So when you add in hot water, appliances, plug loads, all these other energy sources. There are other criteria, and it's just nice to know that these things are there. Things around ventilation, moisture management, quality assurance, just a lot of other things that are baked into it that are sometimes called soft criteria. But really, those performance criteria metrics are the big ones. We're not going to jump into the numbers today on what the metrics are, but I just want you to be aware of sort of what buckets they fall into, what are the categories of things you're being concerned with. Where this comes from are actually 2 different places. There's 2 passive house organizations out there that provide passive house certification. There's the Passive House Institute, or PHI, and then there's the Passive House Institute US, or PHMass. Passive House Institute is based in Germany, and it's an international standard. So they certify buildings all around the world, including here in the US. PHMass is based in the US, in Chicago, and they certify buildings mainly in the United States. But for you guys, the key thing to know is that if you're going through the passive house process and working on a passive house building, it could be either one of these in this location. It could be a Passive House Institute certified project or a PHMass certified institute project. This is something that more the developer and passive house consultant will sort of be working on, but they do exist. So it's kind of good to know they're there. Both of these organizations also provide accreditation for professionals. So the certified passive house builder, certified passive house trade person trainings, or the certified passive house consultant, those type of things that are out there are provided through these organizations here. So I said I'm not really going to dive into the metrics today, other than this one. I am going to talk about air tightness, because I think for the construction phase of the project, really air tightness is the biggest concern, and it's the thing that the widest amount of people have an input on. A wide amount of the trades that are there, folks who are working on this project all through different parts of the timeline are going to be concerned with the air barrier. So what you're trying to achieve is 0.6 air changes per hour at 50 pascals of pressure. And that compares to what you might see in the typical energy code of about 3 ACH50. So it's a pretty significant improvement. And we'll talk about, I have a few slides I'll talk about with air tightness, and I'm sure Ed and Nat will hit on it a little bit with their projects. This is kind of the big number to keep in your mind during the construction phase, and what you're really trying to hit and focus on. But what are the features? What do we actually see through PHMass projects? So here are kind of the main ones. So continuous thermal insulation, where throwing a big blanket over the building, keeping the heat in winter. Thermal bridge-free construction. So eliminate places through the building envelope where heat can transfer. That isn't insulation. So this could be things like wood studs, metal fasteners, steel beams. All these things are thermal bridges. So we want to eliminate them, or at least reduce their impact. We also want an airtight envelope, as I mentioned, is critically important, and we'll talk more about it. High performance windows and doors, so just better performing windows and doors. I'm not going to go too in depth on that today. If you guys have questions, you can ask a little bit about it. But I'll just say it's easier to get windows and doors now that work in PHMass projects than it used to be a few years ago. So there's a greater availability, some costs have come down, so it's a little bit easier to solve that problem there. We also look at optimized solar heat gain. This just means, for example, in the winter months, we want to encourage sunlight into the building as a source of heat. But we also want to figure out shading mechanisms and other ways to keep that from overheating the building in summer. Balanced ventilation, so this is incredibly important. This is the lungs of the building. We make it incredibly airtight, but then we have this dedicated way for the building to breathe through a ventilation system, usually an energy recovery ventilator is what we're talking about there. And then efficient and minimized mechanical systems for heating, cooling, hot water, and so on. So I'll just show you kind of examples of the building envelope, and that's kind of the key thing that I'll be focusing on today. So I think I have 3 projects here to just kind of show you kind of what they did. So this is Finch, Cambridge. This is a 98 unit project in Cambridge, Massachusetts, all actually affordable housing projects as well. But they did 2x6 wood studs that they dense packed with fiberglass, which is kind of a pretty common way to do the envelope. Usually in a 2x6, maybe 2x8 studs I see sometimes as well, and then dense packed fiberglass or dense packed cellulose tend to be fairly common. Over that, they put some basic sheathing material, I think some type of like OSB sheathing material, nothing too different there than you might see in typical construction. Right on top of that, they put an air barrier, and that's what you see in this photo, the blue material. Apologies, it's a little fuzzy photo, but the blue material is an air barrier membrane. In this case, it's a product from Sega. But that's a membrane that gets applied to the top. You kind of put it on in big sheets. You overlay the layer in the seams, and then you kind of tape everything up so everything's very secure there. And if you apply it right, you get the tape on there for all the seams and penetrations, you get an airtight barrier, and that's what they used. On top of that, which this photo doesn't show, but what they put directly on top of that was their continuous insulation. In this case, they used mineral wool for their insulation. So here's you can kind of see this is just basically the sheeting at this point. This I'll show you more. So this is on the left, you're seeing the Sega membrane. On the right, you're seeing the mineral wool. That's the brown material that they use for continuous insulation. What you can kind of see on the left is the mechanism, I guess the device they use to attach the mineral wool. In this case, it's something called a Cascadia clip, but it's a way of reducing the thermal bridging for fasteners. So they use those to attach the mineral wool to the outside. And then they put a little rain screen and then the siding on top of that. And here you can kind of see, so the thermal insulation layer obviously is really instrumental in providing thermal protection for the building, trapping heat in, but it also works to offset the impact of thermal bridging. So here you can see 2 photos. In this case, we're on the inside of the building, looking at the exterior wall with a thermal camera. On the right, you're seeing an image, or sorry, on the left, you're seeing an image before that continuous layer of mineral wool was applied, and on the right, you're seeing after. You can just kind of see, the impact. Look at the studs, for example, on the left, and the heat transferring through them. On the right, you have a much much less heat transfer, and that's because the continuous insulation also acts as a thermal bridge. Excuse me. But when you do stuff like this, you do have to kind of, really pay attention. So this, you're seeing the dense packing of insulation. You're seeing how, they noticed one area where it wasn't done correctly and they needed to do it differently because it was too compressed there. And that just gives you too many little pockets and little areas where you don't have insulation or the right amount of insulation. So how the stuff gets applied is important. Here's, some plumbing penetrations. So this is, an example of when you kind of put something through the air barrier. Well, how do you deal with that? You got to seal it up properly. So you kind of have the one on the left, that wasn't good enough. So they have somebody go through, check that and see that that wasn't right. But the one on the right side, that's kind of the properly taped seams. This is just meant to kind of show you examples of how you think about that air barrier through the envelope. So obviously we want the airtight barrier, but then when you put these penetrations through it, you got to find ways to seal those up so that they're not creating air leaks. So this is Harbor Village. This just finished up in Gloucester, Massachusetts. This one you can kind of see here, similar to Finch in that it used 2x6 wood studs. They dense packed with cellulose this time instead of fiberglass, but I mentioned both of those are pretty common. I'll show you, I think I have another photo here. Yeah, so they use a similar sheeting material over those studs, and then they put the Siga material, the same air barrier membrane, but they used a different type of insulation. In this case, they used a dense foam boards, which is the pink material you're seeing going up. So this is another common type of insulation that we see in projects, like dense foam. So a lot of cases we'll see mineral wool, we'll see dense foam, polyiso is another material we see a lot in as the continuous insulation layer. But other than that, this is very similar. They put a rain screen on top of the insulation, and then they put the siding. Here is showing you an example of some of the air leaks they identified though. So they did blower door tests on this project multiple different times, and that allowed them to identify air leaks early in the project. So now Ed can tell you a little bit about some air testing on these and some stories, I'm sure. But this just kind of shows you, kind of examples of penetrations through the envelope. We are seeing air leaks and how you, kind of fix them and identify them. In this case, you might use some spray foam in those air gaps, or you might put some tape on there, ways to seal those things up. Another project I want to show you, this is Wheaton College Pine Hall. This is at the University of Wheaton College, where they, Wheaton College, where they built a residence hall. And this is just, I just want to show you this because this is a steel frame project. Other than being steel frame, though, it's very, very similar to what we've seen so far. They dense pack the steel studs with insulation. In this case, they use mineral wool as the interior insulation. Then they put, this sheeting material on the outside. Let's see if I know the photo yet. So you can see in the top right, now they're putting up that blue material, which is Siga. So again, we're seeing a very similar air barrier system. So even though this is a different type of project, a steel frame project, they're using the same air barrier system. And in fact, they use the same insulation as well. So directly on top of that air barrier, they put the mineral wool insulation. So the exact same type of continuous insulation. The biggest difference is because the steel beams have more thermal bridging problems with them than wood frame do, they needed more continuous insulation. So they used 5 inches of mineral wool. Finch Cambridge, for example, the first one we looked at, only needed 2 inches of mineral wool. But this just gives you an idea that you can, build whether it's steel framed or wood framed, you can use some of the same methods, some of the same materials, and achieve the same results. They just, there might be some minor differences here or there. You might need to use more insulation or less insulation depending on the project, but you can use some of the very similar techniques and similar materials. Here's just some examples of the walls. These, I won't really explain these because this is just kind of what we went over already here, but please ask questions to get if you have them. The last one I'm going to show you is Tracy Community Housing. This is up in New Hampshire. And this one I like just because the story, they set out to be a net zero project. So this did not, they were not thinking of this as a passive house. They in fact, they were not familiar with passive house, either the developer or the architect. But in coming, in trying to figure out how to build a net zero project on site, they came to passive house as their solution. So they built this to achieve passive house, which they did, and they did achieve net zero, seeing with a little bit of an overhang of their solar panels there on top. And now both the developer and the architect have been given presentations on this, and it said that they're not looking back. They want to keep doing passive house for the next projects. Here you can see some examples of things they did. So this is just, obviously just a shop drawing here, but you're seeing the red line, which in this case, the air barrier. This becomes kind of a key way that, teams communicate the air barrier. and the importance of the air barrier by making sure it's highlighted in kind of all these drawings and specs. It's just highlighting where that air barrier is, what material it is, and sort of how it's going around some of these key transitions, which in this case you're seeing the roof to wall transition, or sort of that parapet to roof transition there, and sort of how they solve those problems. But here it's just going up. In this case, you can see wood frame, just like before. The difference here is polyiso, so that's the foil, kind of almost aluminum foil looking material they're seeing, which is another type of insulation you can use on the outside. So I don't really want to talk too much more about this and take up too much more time, but there's the finished project there. The last thing I want to talk about is just a few more points on the air barrier. So this is, I want to thank Stephen Winter Associates for these couple of slides. This is just highlighting a project that they worked on and kind of showing the importance of the air barrier. So in this case, zip system sheeting, which is brown material that you're seeing in the image, was used as the air barrier. Zip system is both a sheeting material and it has a dedicated air barrier built into it. You might see it as either brown or green. The difference is just the thickness. Otherwise, it's the same thing. You tape all the seams with that black tape that you have there. If you do that right, you have a dedicated air barrier. But the key to pay attention to are the transitions. So what's highlighted, in the red circle there is the wall, to floor transition. So in this case, you can see the drawing on the right. They highlight that in here, but they kind of did a dotted line there. So I went ahead and did this. Oh, and actually, this is a little bit off. Sorry, the bottom red line should be higher. I apologize for that. But what you're seeing is how they made that air barrier go around from the wall into the floor. So I'll show you here. This is a better example from a different area where they did this right. So you can see how they kind of have that little kind of sealant there between the floor, or between the wall and the floor there. And that's kind of that's important. These transitions are the areas that you really want to pay attention to when you're thinking about the air barrier. And that's all these slides were kind of showing you. Here's just an example. So on the right, on the left, you're seeing zip systems. In this case, the green zip system, but still zip system sheeting. And you can see the tape has, some bubbles in it. It's not completely flat. So that's one of the things that you want to try to avoid. Just make sure the tape is applied right. On the right, you're seeing an example. That's Finch Cambridge there, where they're really carefully applying the tape. That's kind of an example of the detail that you want to apply to that. In the middle, you're seeing an example of this is spray foam insulation that being applied. You can see something where the spray foam just didn't expand right to kind of cover everything. You have a little hole. So nice air little hole there. So that's something you would go back and fix. These will give you examples of sort of ways to think about the air barrier, issues that you might run into. But having the tape applied right matters. Making sure if you're using blown-in insulation like this, it covers the whole area. Those are some key things. So that's the end of my slides here. I'm going to turn it over, and I believe, Nat, you're actually going to go next. So I'm going to turn it over to you. I'm going to stop sharing my stuff, and I'm going to be able to answer questions, and I can present some more stuff later, depending on what you guys are curious about.
Thank you. And I think, does someone have to give me permission? Here we go. Show my screen. So let's see. Do people see, Aaron, do you guys see my presentation here now?
I do. I see it in presenter mode, so I have both the first and the next slide.
Let's see how I would do that.
Yeah. Wish I had better advice. I know.
Yeah, right.
I got to go first before people signed on, so I got to
Exactly. So, there's a way.
As you're working on this, I'll just remind all the participants out there, please use the chat function if you have questions. Obviously, all three of us have material to present, but we're here to answer your questions as well. We really want this to be a discussion, so let us know what you're curious about, both in terms of what we're presenting and other things that come into your head, that related to Passive House construction.
Are you seeing the full presentation?
Yes, now I'm seeing the full thing.
You're great. Hey, I did something right. All right. So my name is Nat Coughlin. I'm with LD Russo, and I was just going to try and infill a little bit with some of our experiences with Passive House. I'll focus primarily on two projects. I've been certified for about 3 years as a FIAS. I was FIAS certified, and now a couple of our staff members have also gotten on since then. In that time, we've completed one PHI project, Passive House Institute, which was a private school facility, the Waring School in Beverly, which was about 12,000 square feet. And then we've completed one PHIAS project, which was a 10-unit SRO building, affordable housing, sort of dorm-style living for the YWCA in Newburyport, which was actually part of a larger market rate net zero energy project as well, but we were asked to take care of this affordable housing piece because we had a relationship with the YWCA. So we've actually got 2 completed projects under our belt. And as Aaron said, this really has a tremendous amount of momentum in Massachusetts. So we actually are in process right now on 2 buildings in Salem, Massachusetts, which are podium construction with parking down below and residence above, which is a new twist from what we had done before. So we're learning as we do that. And then we're about to break ground on 25 units in Lowell, and there's a pipeline building up. And I suspect Dellbrook's seeing the same thing, that more and more architects and more owners are getting on board. Certainly affordable housing has been a big driver of the passive house growth in Massachusetts, but we're seeing it, I think schools are getting pretty excited about it. I'm sure universities will be embracing it too. So we've been learning by doing. The Waring School, we had a very different experience than at the Hillside, and it, I think, can help for people who are entering this to sort of hear some of this experience. We were really fortunate that our first project, the Waring School, we had an architect bring us in who had a lot of passive house buildings under their belt. And so they were able to say to they were able to teach us, even though I had my certification, I just had them walk us through all the critical pieces at every step. And it really did help, and we learned a lot. And I think it set us off on a path to success because our staff was also learning from a team that knew a lot. The Hillside project was in some ways a little more challenging because we had an architect there. The owner was fairly sophisticated, but the architect had not done passive house. And fortunately, we had a little bit of experience under our belt, but there was a lot more feedback needed from us and our superintendent in the field and our subs to work out some challenges before they became bigger issues down the road. So some key things, if you're a builder, if you're a general contractor, or if you're a sub, or if you're an owner's rep or a construction manager, in a lot of ways, I was more intimidated than I needed to be getting into this because a lot of this is just better quality control for things that we were already doing. Air tightness has been getting better. These building wraps and air sealing details are not new. It just takes a much higher level of quality control. I think the fresh air systems are much more critical to the successful health of the building in the long run. So understanding those and understanding the commissioning, I felt like we as a contractor had to get a little more sophisticated and involved in that process. Thermally, Aaron's talked about a lot of this, higher R values at the roof, and you have to coordinate the air barrier, the walls, continuous insulation and avoiding thermal breaks. Below grade, same thing, just more insulation and really watching the air barriers. Window and door products were and continue to be more challenging than I realized they would be when we first got into this. The limitations in what's available in the marketplace are getting better, but there still are very, sometimes it can be challenging to match what the architect's looking for with the budget the owner wants. And timing when you're getting stuff from Europe has been somewhat of an adventure from time to time. And then air sealing details, which again, Aaron spoke to, and I'll highlight some more here. So opportunities for mistakes. I mean, this is the way I often look for things, is you spend your nights not sleeping saying what could go wrong. That's a really helpful process when you're getting into your first passive house. Lead times for materials, crazy these days anyways, and a lot of these products are unique, they're proprietary, and many of them are coming through supply chains that are overseas or based in Canada and have a lot of pieces and parts that it's not as easy as buying your Marvin or your Anderson windows. You cannot assume that anything you liked on the last job you did would be and acceptable as equal or alternate detail, because the FIAS is the math they do on how they calculate whether it meets the standard is pretty unforgiving. So your favorite window or door supplier just may not be up to the task unless you pre-review that with your architects and owners during the bid stage. Failure to plan and communicate to subs, it's the air barrier in particular, it's a lot harder to fix it afterwards than to spend extra time up front. It is a learning experience. Some subs are ready to go. They don't need that much help. Some subs need more help. Some superintendents are kind of the same way. You know, they need to get on board with some new thinking. Caulking and sealing, which used to be sort of an ancillary package to a certain extent, like you would build your building and you'd caulk and seal when you needed to. It's a pretty key package to understand now, and I would add taping to that as well. That caulking, sealing, and taping become really critical, and in fact, hiring subs specifically for those scopes, which might not have been something that I did on some of our other projects in the past, has become really helpful. And then I think a big opportunity for a mistake, especially on your first time round, is just underestimating how hard it can be to get to 0.6. And the later you get in the project, the harder it is to make up those, because sometimes you've buried your mistake. It's almost like a roof leak. You don't necessarily know where the original source is. You just know something's leaking somewhere. So that part is pretty critical. We have run into some issues with designers who are also learning. Windows, it's not as simple, much to my surprise, as saying, is a window a FIAS window and do they all work? Different projects have very different requirements. Solar heat gain might even be different on one wall than it is on another wall. You can't mix and match vendors. So even when there are 3 or 4 passive house window vendors, you might find that only 1 or 2 of them have a product that fits the specific need for the project that you're going to be doing. Again, during the bid stage is a really important time to think about these things. Exterior doors have been a huge problem. I might take the all caps off of that now because we've started finding some better solutions and architects have been adjusting, but it's very hard to get commercial exterior door systems. The hardware can be really challenging with your traditional European doors that are designed for a more residential application. When you put them in a commercial application, things like electric strikes, door operators, access control, intercoms, they can get tricky, but also the United States ADA code is different than in Europe, and the thresholds that make a lot of these doors work really well in Europe don't meet ADA in the US. And we've had projects where designers haven't realized that. They've specified something, and then during the project, we realized you can get your passive house detail or your ADA, and we all of a sudden are trying to reinvent those doors. The fresh air systems, I would also say, I don't know that designers are making errors there, but just really talking about the startup, the controls, what the owner needs to know, are areas where mistakes can be made. And then failure to draw. This is one that we've run into on projects we bid and built. Failure to draw how the air barrier actually works, particularly wall to roof and slab to wall. The typical conditions are often drawn. It's the atypical conditions where sometimes the architect didn't realize that they actually haven't quite filled in the line for how you get from point A to point B without an air leak. And that's where we've run into just a lot of discussions. And we've learned to watch for those during the bid phase and bring them up even as we're estimating. Strategies for success. I've touched on some of these already. And in my FIAS course, they said this, and they were right. Take your pen and draw the air barrier line on a detail. Aaron was doing it in his presentation too. You'll often find that there's just a gap. You can't quite get from point A to point B. The master of caulking and taping, we christened one of our superintendents on the first job. What we found is everything he learned on the first job, and man, he took forever. But everything he learned, he was then able to start teaching us on the next job. So new crews were able to get educated on what he learned about how you tape the inside of a window and have it still look nice while working. I already mentioned making the architect and engineer explain everything really helps early on. And then blower door testing. We were advised that you do one test midway and one test at the end. I've actually approached it with 3 tests. We try to do a blower door test as soon as possible. On our first school building, we actually taped off like 15 or 20 of the windows because we were so anxious to get that first test. Not because we thought we would pass it, but because you put a smoke gun inside the building and then you positively pressurize it and you can see the smoke coming out through all of your little leaks. And we were able to catch some pretty significant issues when they were easiest to get back to. And that's really been a helpful approach for our superintendents. Just as an example, and without getting into too much detail on this, the school building was wood framed and had all these really nice, neat, square conditions where the wood walls and the wood roof system came together and the air barrier worked. But they had one condition with a cheek wall where we had to go under this steel beam that was at multiple levels and had a round column, and our air barrier had to seal all of those conditions. And frankly, we underestimated it. We chased this one out. It didn't pass in our first test. It was a little better in our second test. And we finally chased it out and managed to solve that problem for our third test. But that was one of those conditions that was atypical and caused 75% of our worry, was that one condition that we had not really thought about, and the architect hadn't really wrapped his head around either. So here are just some examples. On the left, you can see in red, I drew where the air barrier was tying together from the wall and into. On this project, it was interesting. They did the air barrier under the trusses at the flat roof because they felt that was easier than going over the top for several reasons. It was a little unusual. And particularly where walls on the inside came up against that, we had to make sure we had all that air barrier in place before we framed our interior walls. And on the right, you can see, again, same project in blue. We were able to draw the underside of the truss to the outside of the wall, and at the bottom, the outside of the wall to the underside of the overhang and down to the slab. Similarly, and this is one that can be tricky as well, is air sealing from the framing to the foundation using regular foam sill seal like you normally do on a house doesn't cut it. You have to really tape that joint. And so we've moved towards doing sort of a T-shaped detail where we go across the foundation and then tape over that whole condition on the outside from the face of the sheathing to the concrete. A little bit belts and suspenders, but it has not been a source of leaks. I think we worried about it more than we had to. Once we came up with a fairly simple detail, it's passed every time. Here's just an example. Architecturally, one issue you run into is that we used to just leave the first 6 or 8 inches of concrete exposed, and then your framing and siding started above that. Once you put insulation on the outside of the building, you need to come up with details to hide that can come into contact with the ground. On this job, they used a metal flashing, which seemed sort of extravagant, but it was very, very slick looking once it was done. This is the Hillside project, which was more of a traditional house style. It had a pitched roof with shingles, had gables and overhangs, and was actually much more complicated to work out some of the details. And the way we did it was the same process. We spent a lot of time early on drawing the details and actually found a number of issues that they fixed during the design and bidding phase that would have been much harder to fix if we'd already had a lump sum price and then they were redrawing it during the job. And that is the end of my presentation. I think I would add, I put that presentation together a few months ago, and since then I think there were a couple of things that I've learned since then that are worth also knowing. Spray foam insulation, and Aaron featured this, and there was a while where we thought spray foam was the great thing for sealing everything. Now there seems to be a lot of movement to recognizing that spray foam can shrink over time, and it does not flex the way caulk or tape does. It's very, very rigid. And so in fact, a lot of projects where we would have said, fix that with spray foam, we've been educated to move back from that. And we actually very rarely use spray foam as an air sealing condition. It's also pretty dreadful for the environment. I still feel strongly, because we're still in the process of turning over buildings, getting owners to understand how their fresh air systems work and how for them to keep an eye on maintaining and managing those is really important to me. I think that's an area that needs more attention than it used to get, because those buildings, if those systems aren't working correctly, that is one of the things that could go wrong. And as a contractor, I feel like we have to make sure the owners know so that it doesn't come back to us or a mechanical contractor. At the school building, we've seen that there's been a lot of learning about what not to fiddle with when you're the owner and you're trying to adjust things because they were changing things. So with that, there's a lot of learning. Good partners make a big difference. And I think all of us, the first building's the really hard one. And after there, you sort of keep fine tuning your process until people get on board. And that's what I have. Thank you, guys.
Thank you. Can you guys see my screen?
Andy, you can go next. I just wanted to mention to all the participants out there, I couldn't actually see the questions at first. I'm only in the chat room. I can see the questions now, so I'm answering a few of them in the question feature, but we'll get to a lot of these as the discussion and after Ed's presentation. So some of these I'm going to save to bring up with both of them at the end of Ed's presentation. But I can see your questions, so keep them coming.
Great. Good afternoon again. Ed Sople, Dellbrook, JKS. Going to spend a little time quickly just explaining a little bit about the company, a little bit about myself, and then we'll dive into, I'm going to focus a lot on the process and a little bit on the details. I'll go into some unique challenges, some cost drivers, some lessons learned, but mainly the experience that we had was from a process perspective. So diving right into, so Dellbrook JKS, about 235 plus employees, 2 offices, one in Quincy and one in Falmouth. We have individuals and staff members with over 30 years experience. We've been in business since 2004, 2005, growing like crazy, like all of us, and enjoying the ride. Jumping into my slides here. Our journey so far is important. Like Nat mentioned, we were very fortunate to have a good teammate and good partners on our first project, which was POA. They were already doing FIAS projects, passive house projects in Washington, D.C. We were brought on and we started in roughly early 2019. Met Aaron, did a seminar downtown and kind of fully got engrossed in the passive house project using the loop at Mattapan Square as kind of our kickoff point there. And then throughout all the way, got awarded, the loop sometime in early 19, midsummer 19 to, today where we probably have 2 or 3 ongoing, 4 or 5 more in the pipeline, and then Massachusetts is heavily incentivized. So the last funding round, we did roughly 13, 14 one-stop applications that were heavy into the affordable housing passive house. But jumping into a few of the jobs that we have upcoming, Ringe Commons is for just a start in Cambridge. This one's an exciting job for us. It has a little bit of residential and commercial, which is awesome. JJ Carroll is actually in construction right now. It's 142 units, 5/1 podium for 2 Life, formerly JCHE in Brighton. Glenbrook Way Phase 2 is a project in Medway. We just recently turned over Phase 1 and Phase 2. We'll be breaking ground here in the next few months. And then Leland House is another 2 Life project that's in the current funding round with DACD 68, 70 units of new construction that will be passive house. Dellbrook JTS is a company. We have 8 certified builders and designers at this point. And then I should have touched on this back. I'll jump back a slide here. We currently have 35 staff members in passive house training with 22 scheduled for certification this year. So as a company, we're all in. Learning and development department has been a big help there, getting us going there. Jumping to myself, a little bit of background, graduated from Northeastern, been in the business roughly 26 years. I've seen a lot. POA Mattapan, the loop is down in the bottom corner there, 5 over 1.5. And the project team, to Nat's point, very fortunate is developers, preservation of affordable housing in Oyster, civil engineer Howard Stein, architect. It was a joint venture between TAT and Mass Design Group. And then the key for us there was, the MEP engineer being Peterson had, a lot of experience with passive house consultant, which played a big role, and I'll get into that in more detail, as well as Claire Result being the sustainable consultant for the project. For us, the loop at Mattapan, post-tension, concrete, 5 over 1, which people have seen a lot of, 135 units, affordable housing, roughly 170,000 square feet, has retail below, roughly an 18-month schedule at the beginning. So the process for us was a good one to learn. In February of 19, kind of pre-construction began. We spent a good amount of time in the spring and summer going through budgets. And for us, we learned early on, Nat mentioned that, subcontractor education was crucial. We were way over budget. We were 10, 15, 20%. We had no idea what we were doing with all this passive house stuff. And, the subcontractors didn't need it. They were scared. They were very conservative. So we used the partnership with the passive house, consultant in TAT and POA. And we learned, processes, and we learned equipment types, and we had, seminars in our office, and we brought in 5 HVAC contractors and 5 plumbing contractors and siding contractors and AVD, and kind of drove the process that way to ultimately get to a controlled budget that worked for everybody. To Aaron's earlier point was one of the slides that ultimately we landed at a 2% delta for the passive house project, which was anywhere like 550 to 600,000 at the end of the day. We competitively bid it in October of 19. Again, staying within budget. To right now, we're in the finishes on one section, and we are completing drywall on another phase. We're probably going to be turning that over in July of this year, which would be a big, momentum for us. That will be our first completed passive house job. JJ Carroll, that I mentioned previously, is under construction now, foundations, and will be our second largest job. So, through that pre-construction process and through all those meetings, we did step back a little bit with TAT. To the point earlier of Superintendent Luke Grady, as well as my project management team, had multiple meetings with TAT. And you take your base drawings, and you need to really draw your AVB. You really need to draw all the caulking joints in your wood panels, and you have all those meetings in pre-construction. You produce a bid set. And the bid set has specific drawings that are passive house drawings that go out to bid, and it clearly gets all those details. So when you do have sub bids, there's no surprises at the end, because these cost drivers, the night wall system, one of the slides that Aaron showed use the Cascadia clips. That's also a method for your girth system that everybody's familiar with on your range screens. It's a cost driver there. Your exterior wall insulation, another cost driver. Your typical AVB windows, was talked about a little bit. You got to get used to the Intis windows, amber line. You got to get Alpen windows. And again, our experience, or POA's experience in other sectors of the country, allowed us to, move away from the, again, I'm gonna get myself in trouble, but the Pellas of the world and the windows that you're used to seeing in residential applications just wouldn't work. So we had to familiarize ourselves with these new manufacturers that are getting better and better. They do have some delivery challenges now, but they are getting better as we go. A big one for HVAC systems is a product called AeroSeal, which I highly recommend. We use it religiously on all of our jobs to seal the ductwork. Air tightness is one test, but another big test is your duct leakage test. That's part of your certification, and the requirements there are pretty strong. So highly recommend that you buy out AeroSeal for your ductwork systems there. Armor wall is something that, thermal bridging is a big piece of what you learn. With passive house, you can't have any thermal bridging. You won't pass your tests. Your R values go way down, whether it's, and so one of the big pieces, either you have canopies or you have balconies or, penetrations in your facade you need to deal with. And the way they get around that now is, the night wall system has thermally broken, fasteners, but also they have these blocks that are made from Armor Wall and Fabrica and a couple other manufacturers, and they're structural blocks. And you attach those to the outside wall to continue your thermal break is a cost driver. Compartmentalization is a big one. Getting that, we actually have a subcontractor who's just dedicated to these details. We have an assistant super and a superintendent that are dedicated to these details. To Nat's earlier presentation, it's a big piece of through. And then the plumbing, as funny as it sounds, plumbing, there's a requirement for, I think it's like 0.6 gallons max to get your temperature rise of 10 degrees. So if your recirculation lines aren't done correctly and your piping isn't done, your loss, we won't be able to meet that plumbing requirement. So typically plumbers just run wild. It's something you really need to pay attention to is your domestic hot water, especially right now. It's still staying in the gas range, and then whether we go electric or not is something that more and more projects are seeing there. So those are the big cost drivers. And again, that going back to the pre-construction phase, that 2% thing, I think we were very fortunate where the original budget that POA had for the project was, I think, in tune with what Massachusetts does. It had the stretch code, it had all the bells and whistles in there, so we weren't starting from a very low baseline. And I think that's sometimes where projects get in trouble, where they start at a different value, and all of a sudden it's 6%, 10%, higher numbers. If your project has stretch code already in it, and the mechanical code already in it, fresh air is a requirement now, and exterior insulation, everybody's doing rain screens. So it's really not that big a deal as long as your baseline is in the right spot, would be my recommendation there. Unique challenges, the two gentlemen before me hit on a couple of them. Testing requirements, we actually purchased a blower door unit, highly recommended. We test the same way. You get through framing, you get your exterior insulation on, you test then. And then going through, my passive house certification, it was kind of funny when they mentioned it, that they want you to test right at the beginning, because they mentioned that you're going to get, your results get worse as you actually complete the building. It was a wild concept for me to understand, and thinking that the more stuff you put in there, why wouldn't your air tightness get better? It absolutely gets a little bit more challenging. So you want to make that investment up front, and you want to test early and often. So you can find your mistakes, and the smoke does help you out, because as they mentioned, the further you get in, the more stuff you actually put in place, the harder it is to fix a problem, find a problem, and time becomes your enemy, unfortunately. And that's just a big lesson learned for us. Huge challenges. Duct leakage, I mentioned there. The plumber, you're going to have to educate your plumbing subcontractors. They're going to need to understand that. PT slab penetrations with all this podium stuff. Nat mentioned and showed a couple slides. Your penetrations are super important. And then, trash chutes and first floor retails, dealing with, these areas, like I mentioned here on my lessons learned, having all these penetrations sealed is a big, challenge, but also a lesson learned for us. So touching a little bit on, 4 or 5 of these lessons learned for us. Coordination of the night wall system. Again, it was more of an educational thing with the subcontractors, getting the right vendors and getting the right, installers to be comfortable with it. Costs associated with the VRF, a lot of your HVAC systems in Passive House will go into this variable refrigeration flow systems. You know, sealant and AVB scopes, you can't just give it to the drywall guy. You can't just give it to this guy. You gotta have a trade that has specialized men and are used to doing this scope of work. And then panel shop drawings are crucial. You know, sealing of the joints during your panel shop drawings are a big piece of it in lesson learned for us. And then I'm going to try to share a couple details. Hopefully I don't screw this up with, can you guys see the plans from Mattapan?
Yes.
Okay. So this was like an ASI architectural sketch. This is our roof to wall detail. As you'll see here, we ended up getting almost close to an R50 roof. But the red line is the crucial piece where you got to come up your exterior wall and onto, you know, your roof sheathing, and that's more of a coordination issue because people are used to, your frame is used to doing your parapet, and you got to actually do the AVB first, and then you do your parapet later. Was a big lesson learned for us. Over on the right side here, you have a lot of these HVAC equipment that gets mounted to the roof. You got to add the insulation below there. Was a lesson learned for us. And a cost driver, again, just following more AVB details down here. And here is a piece, this member in green is from Fabrica or Armor Wall, and that's where you see you get your thermal bridge there through that structural member, and you don't penetrate, and you don't get your R value loss. But it's definitely a cost driver. Those get very expensive, but it definitely needed. And then again, dealing with your podium situation, you're going to see a lot. Again, this red line, your air vapor barrier is super critical, and making sure your thermal bridges from your podium to your exterior wall. The exterior wall construction on the loop is 2x6 studs, you know, fully packed cavity, and we went with 3 inches of rock wool because we had, you know, type 3A construction. And again, just more same details. These drawings clearly highlight your AVB. And your thermal bridging is something that you just got to get your subs educated and comfortable with. And that's all I have. Questions? I appreciate everybody's time. I talked real fast and quick as I always do. But thanks for your time, and open to the questions. Again, once you go through one, you know, we have a bunch of people doing the certification. That's a little overwhelming. It's 30 hours of intense every day. You feel like you're going back to school again, and you realize why you don't want to go back to school again real quick. But it's a lot. But ultimately, building one and seeing it go together and seeing what it takes in the pre-construction process to educate your subs. And, you know, I equate this a little bit to the whole lead thing, where lead was a whole big deal. You know, I talk about it all the time. Lead basically becomes second nature. And Passive House is going to get there. And I think it's more of a long-term. You know, I think Aaron mentioned this. At the end of the day, you're achieving this stuff, and you're reducing your energy costs at the source. You're reducing it by 40 to 60% on the jobs. It's really a sustainable process that, you know, the owners are going to see long term. And that Cambridge job that was up there is already seeing it 1 year into operations. The energy costs are going down, so the owner's seeing that, as well as, you know, talking about durability and comfort and all that stuff. It's all true. And once you build one, Nat's point is you get intimidated by the process, but if you have good partners that have been through it, they will walk you through it, and a lot of it is good typical construction. So thanks again for your time.
Great, thank you, Ed. And I think both of you hit on this point that this really is about the craft of building and kind of just paying attention to these details that may not be as important in a non-Passive House project now become incredibly important. So I'm kind of curious. There's a question that came up here from the audience. I'm going to ask a version of it here. Is obviously both of you have gone through various, you know, whether it's PHS or PHI training success with your staff. But how are you working with your trade partners and with the subs that you work with to, you know, educate them on these details that they now have to pay attention to and make sure they get them right? What are some of the strategies you found for sort of managing these subs?
I'll just continue on what I was talking about. Bringing those subs in, it's crucial. You have to get them comfortable like anything. You know, they were not comfortable at the beginning, and their prices reflected it. So you need to bring them in smaller groups, or bring your architect in. We brought in Peterson, the MEP engineer. We brought in, the passive house consultant, and you walk through these details. And once you get foremen and you get project managers or estimators, and they see how we could put it all together, and they get comfortable with the manufacturers, and that would be my recommendation, having those meetings up front. We spent a long time in pre-construction, thanks to the MBTA, a little bit longer than we thought and wanted, but that allowed us to, when we hit the ground running, we were all bought out, we were all coordinated. Maybe not every job will be that fortunate, but a lot of pre-education. So when you get into the field, you can't learn these as you go. You learn these as you go. They're going to be a nightmare for you. You have to pre-plan, and that's why it's kind of funny. You need drawings. You need drawings, and you need to have those compartmentalization drawings, those ABB drawings. It would be my recommendation. That will keep your cost in line. And then ultimately, keep your change orders down. The change orders have been very minimal because, again, you have these conversations up front, and these subs are educated, and they don't need to come after you for this stuff because you have it all covered. At least in the new construction piece, we haven't done a rehab yet. I'm interested to do, passive house on a rehab and see how that goes and how it's related to there, and see if we can have the same success there that we have on new construction.
And I would just add that recycling that educational process, like we got educated during the pre-construction and bidding step, but then we basically went back to square one during construction to get the superintendent and the foreman, because like the guy in the office may understand it, at your framer or whoever it is, the HAC, but if that doesn't get communicated to the foreman in the field. So we found that those really early sort of pre-construction meetings with the field management made sure that everything we put so much effort into with the owner and the architect during the bid process and with the subs didn't get lost. So we sort of cycled back multiple times. Was really helpful for the new people.
That's great. So really this communication, constantly having open communication and starting it early, bringing people together early on in working pre-construction. There's a question here about the timeline. Are you seeing with some of these details how does this change the construction timeline for you on these passive house projects? Does it?
I found that with enough planning, it does not need to have a really substantial impact on the timeline. I do think you need to carve out a little bit of time related to doing the early blower door tests and then cycling back to address the issues you found in those tests. So there's some added time there, particularly if you're having to temporary close in windows or roof openings or something like that. So but it's certainly any time you put in at that stage, hopefully avoids delays later on. But there's some incidental specific tasks that add, but I don't feel like whatever we thought a building took is just totally changed by getting into this process. I think there's some specific details that add a little bit, but if you manage them right, really, I think just like costs went from being 15% difference down to 2 to 5% difference, I think the time, maybe the first one you hit a few bumps and it adds a lot, but as you get better at it, it really shouldn't transform your timeline if you order your windows really early.
And I'll piggyback that. That was the recommendation. Again, we were very fortunate to have an owner who had already built them, and they said right up front, don't underestimate, plan for the mock-ups, do 20 mock-ups and do blower door testing. We built that into the schedule, and you can continue on other activities. And if we didn't do that, and then you find problems, would be my only, that's kind of a doom and gloom scenario. If you get yourself into a situation where you start to fail your tests, then you're going to get into a little bit of panic mode, and then things might stop and things might get delayed. But if you plan accordingly, you're still doing a roof, you're still doing a wall, you're still doing a little bit extra caulking in the unit, and you're doing drywall. I mean, at the end of the day, it's the same buildings we've been building for a long time.
That's great. So it really sounds like the extra time is up front in the pre-construction phase, where you're really putting in the work then, and then the construction phase doesn't have to take long. But it sounds like the key, and this is, I think, true for passive house overall, is just bringing people together early on, getting started with these conversations that you may not have had until you were on site in different projects, and kind of figuring all that out beforehand. If you do that planning, it doesn't have to take longer. And with that, I think that also is one of the big reasons costs have come down. We've seen it go from 10% down to this 1 to 3% phase. There's been a couple of questions about that here in kind of the costs. So how do you guys kind of, and Abby, you've talked a little bit about cost estimating in the past, and how do you look at, I guess, what kind of cost premium have you guys seen? Where are you noticing it? Is it the heating and cooling equipment? Is it the windows? Is it the building envelope? Like, what's sort of driving the cost increase that does exist? And the kind of follow-up question that's also here is, how does that compare to the return on investment that developers might see from the lower utility bills? And you talked about how Finch is seeing that already a year into operation, but is this something that comes up in your conversations with developers that you're working on? Are they looking forward to saving something on these utility costs?
Yeah, I mean, again, we went through recently with my passive house. Dan was very good about, talking about the return on investment. And I guess in the country, they're seeing jobs that are actually going in the negative in a good way. They're actually, cost. But for us, it's lessons learned. We have a cost database that we build on. So our estimators, have that database. You hit on all the ones. Your roof insulation is going to be more. Your exterior wall is going to be a little bit more. Instead of 2, you might get 3. Instead of 3, you might get 4. Your girt system might be a couple more dollars a square foot. You're going to spend some money on caulking and taping, and it's money well spent. Your HVAC, the market's really getting competitive with the VRF. That's more of an educational and a trade thing. The more HVAC guys that can do it, you'll get the VRF to come down. Plumbing is a little bit okay on that stuff. But the only last piece we're trying to get more comfortable with, sometimes the ERVs are getting a little bit costly. Whether it's Swagon or it's Ventacity or all these guys, they are a little bit out of control a little bit, but that might just take a little bit of time to get more people to manufacture them and get more efficient and get more cost competitiveness there. So we learn from that, making sure our estimators have that stuff up front. And then I can't speak to the return on investment. I think the only thing we can hopefully control is the upfront cost baseline versus the final construction cost. And if we build a good building and it's 40 to 60% less energy, and ultimately, again, it's a little bit tough because some of our clients, in the affordable housing piece, there's utility sharing and cost controls, and so some market rate versus affordable are a little bit different. So it's a different question for an affordable housing developer than it is for a market rate. Individual meters, market rate versus sharing of utilities and on the affordable piece. But I think the more, if developers talk to each other, talking to POA, talking to some developers that have been through this a bunch, they'll see their return will be okay.
It's interesting too. I will say, like the windows, these European style tilt turn windows, they're expensive, but they're sweet. Like they're really nice. And like honestly, you look at them and you're like, that's a high quality product. So it's not necessarily just a premium because it passes some certification. It's a little bit slicker design and a little bit better product. So it should cost a little bit more, but I think they as Ed said, I don't necessarily see the return on investment math, but it does make sense to me that you are getting more. You're not just paying for a stamp or a label. They really do have performance differences that you're paying for. So to a certain extent, that's the way of the world. If things become a little more sophisticated, they cost a little more, but they do serve the purpose a little better than what we did 20 years ago.
And I think that's one of the major differences. You hit on it with LEED. LEED was like a check the box type of thing, and you check a bunch of things, and that's great. You're LEED certified, you get a plaque. But passive house is kind of performance driven. The math's not going to lie. So that's, I think, the major difference between the two.
Yeah, I think those are all great points. And now you were talking specifically about windows, and I know you mentioned some challenges right now, and maybe the supply lines. They're getting some from Europe and sourcing them. So there were some questions about that. Some folks were worried about, how do they get these products? So I know I've seen some American manufacturers here, even in the Northeast now, making windows that work. I'm curious, you guys have experience using some American or more local products? How are you having, and I guess, are you having difficult sourcing other materials as well? If we look at, say, insulation or air barrier systems, or is this mainly for windows and doors where you're kind of seeing some of those sourcing problems?
early on for us, it was windows. You know, interest was a challenge. Alpin was a challenge. They're getting better. You know, Amber Line is a big one. They have a Boston-based or New England-based office now, so that they're getting more under control. And then, you know, roof insulation, wall insulation, they're not really passive house issues. They're really, you know, COVID / what the world is issues. So I wouldn't really blame them on passive house. They're just, whether you have a passive house job or you have a non-passive house job, we're dealing with all the same nightmares as lead times and cost, you know, product availability. And, you know, I spend 3/4 of my day dealing with phone calls with escalation. So it's awful, but we're getting through it.
You too, huh?
Yes.
Not just
I'm being generous with the 3/4, but it's a lot.
Yeah, I would agree. There's more and more vendors. A lot of them do have sourcing of materials. It's a global supply chain, and a lot of materials that make those components are still European. But I think, as with everything that happened in supply chain in the last 2 years, part of it is just readjusting your expectations about how long things take. And if you think 4 months instead of 4 weeks, you avoid a whole lot of headaches just by taking that approach pretty early. But we try to release the windows when we're releasing rebar. Like, you just need to get ahead of it pretty quickly.
Great. I want to shift gears a little bit and talk about the certification process. So you guys obviously talked about a lot of things that you have to do different in terms of planning to achieve it, but what have you noticed about actually going through the certification itself? I'm sure both of you have worked with a passive house verifier on your projects. What are the steps you have to take in terms of, say, documentation in order to make sure that you're actually, you know, achieving what you need to for FIAS or PHI to certify it?
I mean, in my experience, that part hasn't been too onerous on us as the contractor, as long as we talk pretty early with whoever the rater is. You know, they have a pretty high standard on what they do, but they fill a lot of that role. They come out and inspect things, and if they need pictures, you got to take a ton of pictures. You know, you don't want to cover anything up without them seeing it, because they can, you know, they need to be able to say with some certainty that you did what was designed. But a lot of that process, at least on the projects we've been on, it doesn't add a ton of additional onus. And actually, in reference to like the way LEED used to be, which was a tremendous amount of paperwork and documentation, passive house is much less like that. The raters come out and they make sure you're building what was designed. There's a little additional, but it is important to have someone doing those inspections who's kind of like on your side as a team member. You know, you don't want someone who's sort of letting you fall in a hole. You want someone who comes out and helps you guys keep from falling in a hole. But then it goes pretty smoothly, actually. They're a good quality control check on what's going on in the field.
I couldn't agree more. You get them involved in the mock-ups. They dive in, they become your partner. But you'd be foolish not to tap into their experience. But they're like kind of like, they're all over it. They're excited for it. They're really, really passionate about it. They want you to pass. They want you to do well. And then they come out and you're just going to be good with your 3-week look aheads. You're going to be good with your monthly schedules. You plan them out. Hey, I need you this many times, because they have to see certain things. You know, photos will get you so far, but they also have to physically be on site to see certain pieces to verify before you can move forward. But it's definitely less than LEED. There's no more material calculators and all that paperwork we did with LEED.
Well, that's great, and I think those are good answers, because I think that the certification process sometimes is the idea of that scares a lot of folks to know that for you guys and your experience, it's actually maybe even simpler than what you had to do for LEED, and it's not that hard. And I think the key there, as you mentioned, is getting the early start, working with that rater, early on, and knowing when they're going to be there, having them on your team and kind of a part of your team. So that's great. There were a couple questions about kind of the roller door test aspect of this. Obviously, you have to do a whole building test at the end for certification, but you both mentioned doing it earlier on. And I mentioned that as well, that I've seen in a lot of projects. One specific question was, how are you dealing with that early on when you have things that are open? So you have open soffits and ridge vents. Now you mentioned you have open windows that you're covering up. Are you going around sealing all these things temporarily? And what does that add? What kind of complications does that have? Obviously, you have to spend time doing that. You might have to have people out of the building while you're running the test. you both see benefits from this, but what are the challenges to doing some of these earlier blower drawing tests? How do you avoid this?
It's just planning. It really is planning. Having the subs buy into it. You can't ask them later, then you're going to deal with change orders and all the other nonsense. So doing it up front and having it planned is critical, because going back to your earlier point, the one thing I would say about what's a little bit the most scary thing about passive house versus a lead is you're either passing or you're failing. Where lead and some, the HERS rating and all that stuff, you can kind of work your way through it, and there's a range, and this is you're either passing or failing. So I think that's why I would encourage people to get this blower door test done up front, and whether it's a mock-up or getting things built ahead of time, you got to spend that money because you got to go through, and then maybe over time it will become just typical details that we don't need to do. But right now, in this first initial couple of years, spending that time, and again, just it's communication and planning, and would be our take on that.
Yeah, I feel the same way, and I will say I think we have one superintendent who's on his third project. He's had some involvement in all three of these projects, and so it's a little easier there, because if the blower door test needs to get delayed a little bit to save some of the jumping around and doing rework, he's got that level of knowledge to know like where his comfort level is. So I do think the more projects we do, the smoother that will go. But yeah, the fact is you sometimes just have to go tape off a whole bunch of things that you wouldn't normally have done just so you can run that first test. And you're not trying to pass at those places you taped off. You're trying to just pressurize it enough that you can test everything else. Because it's the leaks you aren't aware of that catch you. The ones you know need to be temped in are already there.
And that's a great way of putting it. The leaks you don't know are there that you're trying to find. And I like the example use of the smoke test. I've seen that on other projects as well. Just kind of seeing that go out. Really can find those little leaks. So shifting gears here again to kind of the barriers, the air barrier. There's a question, actually, a good one here about air barrier and vapor barriers. I know sometimes air barriers are vapor barriers. A lot of the examples I've seen, though, the systems you're using, the ones that I showed, are vapor open. So are you guys using vapor open assemblies? Are you seeing other materials that you're using for vapor barriers if it's not the air barrier? I wonder if you could comment on that and maybe a little bit about how you see these assemblies performing in terms of being able to dry out.
I mean, our first couple of jobs, it's an air vapor barrier together. It's kind of what I've seen happen. There is some talk, or there is some climates, or there is some areas about using smart vapor barriers on the inside for like Gillette and letting that the vapor drive on certain seasons. But we haven't seen it ultimately be required once you went through the WUFI passive model. We ended up on both jobs just dealing with a combination AVB, and it's worked out fine.
Yeah, it's interesting. Your slideshow, Aaron, you featured Zip and the Sega wrap, and that seems to cover jobs we bid and jobs we built. That covers most of them. Those two approaches cover a lot of ground, I think.
Okay. Great.
And that the only thing for that, we love Zip as well. It's just when you get above a certain story, then you get into your type 3 stuff is where you get into your exterior fire rated walls, and unfortunately you can't use Zip. And then a lot of the funny thing is a lot of waterproofing consultants aren't really big fans of it. So you're competing, passive house is competing against your typical waterproofing consultant that doesn't like that the joints aren't shiplapped. They have this whole thing about the tape, but it's definitely AVB one process is the best way to do it.
Great. So this is all the questions I'm seeing actually in the Q&A. So if other folks do have some, now is the time to get them out there. We're gonna be running out of time soon, so we have more. Please get them in here. But both of you guys, Ed and Nat, I want to thank you for being part of this presentation today. Both of you you've given a lot of presentations up in Mass as well. You've kind of become real advocates for Passive House. So I really appreciate it from both of you. Let's see. Is there, I guess, I'll just turn it over to you to see if you guys have any last words of advice for folks out there. Maybe I'll put it this way: things you wish you knew on your first pass out project.
I would pay the general contractor more money. Don't worry. I put that passive house line in there. If there's developers or something, But in all honesty, it's the pre-construction. We invest a lot of time and money in there. So don't underestimate the amount of effort and energy. And it's good to have architects and engineers and Again, we were just our partnership. Our owner had their game on. They knew they had to spend the money with the passive house consultant. All the paperwork was done. It was kind of maybe too easy for us, kind of seamless. They knew what they were doing, type of thing. And maybe we will have somewhere where we have to educate an architect or an owner or an engineer a little bit more. So maybe coming out the gate, we're very fortunate. But I think I'm just nervous that escalation and everything else is gonna throw a roadblock into this, this process. And, when all the DHCD starts, awarding projects in, July and August or whenever they do, there's going to be a lot of jobs that are upside down. And that's no fault of Passive House, but, crazier things have happened. And even though it is only 1 or 2%, it's going to be an interesting dynamic to see how DHCD plays that card and, how we get these jobs back in line and hopefully escalation. And, if I can control, we try to close these jobs and start them up in 23 is kind of what has me losing sleep every night. And,
Yeah, I would say just as far as maybe lessons there, we were very fortunate, and I think Ed was too, that our first experience, we had a great architect and owner who really knew a lot. And I would say if you're a contractor, I've been a little leery about some jobs where it's an architect who's never seen it before and an owner who's never seen it before. Like those can be, that might not be your best first opportunity to jump into it. But if you have an opportunity with an architect and an owner who have some investment and some experience and knowledge in it, I would jump for it because it's kind of a matter of time for a lot of contractors. This will continue to get cooked into the cake of regular building pretty soon. So if you have a good partner, go for it. You learn a little bit and then you're off and running.
Great, good advice. And as you guys were talking there, we had a couple more questions pop up, so I'll ask those for you now. Ed, you mentioned aero barrier, I believe, earlier. Do you guys have any thoughts on the effectiveness of aero barrier as an air barrier system?
The aero seal, you mean?
Yeah.
We've done the aero seal. We have not done the aero barrier.
Okay.
That came up in my in the class on the when I was going for my certification. A couple projects. One was in New Hampshire, and somewhere they were using that aero barrier. I know it's new. We haven't seen it yet on a job dealing with that, so I can't speak to the aero barrier, just the aero seal.
Yeah. I've seen it used in a few actually retrofits where they'll spray from the inside and kind of get into. It's really nice. For those unfamiliar with it, you kind of do a highly pressurized. I can't remember the exact material it is, but it's this pressurized material, and it goes into all the little leaks and crevices in the building. So it seems to be effective. If you on an existing building, you have to cover everything up you don't want covered, but it seems to work okay there. I don't know, Nat, do you have any experience using it?
I don't actually. I'm familiar with the product and the process. I think it's, I'm sure it'll come up, but it's not, we've managed to not need that in the course of our work so far. But I think it's great to know those systems are out there because I do think there are going to be times when they'd be pretty critical to help in a project that needs it.
That's right. When it did come up in the class, they used an example of, I think, either a mill or a rehab with brick and, a wood ledger, a whole bunch of fun stuff that comes with those mills. That was a product they used on the inside.
Yeah, it seems to be a good solution in those applications where you kind of have that existing wall in one place you can't get into, or maybe as a kind of a last second kind of air check there. If you've already gone through your typical stuff, but you're still seeing some little air leaks that you can't find, you can use that to hopefully address them. Because that's, I think, the nice thing about it is you don't need to know where the leaks are; it finds them for you. Another question just on insulated slabs. Obviously, if you do a concrete on grade, you do need to insulate under that. But have you guys do you do concrete on grade slabs? And are you doing usually? I see mostly like SPS or EPS under the slab. Is that what you guys see?
It's a good thing to pay attention to in pre-con. On a job recently coming up for wind development in Shrewsbury during the again the pre-construction meeting with the consultant and the person who was doing the woofy passive model. It's nice. It's a workable model. And it comes up where it's red, you don't pass, green, you pass. And they were throwing in 1 inch, 2 inch, 4 inch rigid below the slab. And you can see when they got to green, because it is dollars, it gets pretty costly when you try to get 3-4 inches of insulation below. But it's definitely part of the whole woofy process. Is definitely a continuous slab insulation.
Yeah, I like that point as well, is that for both of these, whether you're going through FIAS or PHMass certification, there's energy modeling software that's being used, mostly by the designer and the PHMass consultant. But it's great that you guys are involved in it as well, and kind of in seeing the output. And you get to know, like you said, you get that green box or the red box, if you're doing this. So I think for a lot of projects, the key, that before you ever start building the project, whether you're going to hit it or not. But that airtightness is where it comes in. So I think you guys hit on it, I hit on it, but for everybody, still out there today, just keep that in your mind. That airtightness target is the big metric, and the more you can get your team, the subs, kind of focused on working together to make this building airtight, the more successful you're going to be. Those are all the questions there. So I got nothing left to say. This was a great presentation. Thank you guys. Thanks to Keegan and Anna and the folks at ICF for putting it together. And thanks to the great folks at Connecticut for all their work in Connecticut, getting some of these incentives off the ground. It's really exciting to see them there now. And I'm looking forward to seeing that huge building boom in Connecticut that we've seen in Massachusetts for PHMass projects.
It's great. Thank you, guys.
Thanks, everybody.
Thanks, everyone. I wanted to just have a quick message before we close out. The deadline is tomorrow to sign up for a Connecticut-based PHI certified passive house designer consultant training, which is happening April 1st. So the deadline is tomorrow if anyone is interested in signing up for that course. And you can get the 50% cost reimbursement through Energize Connecticut. So if anyone's interested, deadline is tomorrow. That was it. That's all I wanted to say. And thank you guys so much for presenting today. It was great.
You're welcome. Have a great day.
Thank you.
Thanks, everybody.
Bye.